Now that you have a basic understanding of PG problems and using PGML to create them, I'm going to show you some more sophisticated problems and point out specific features which might be helpful for you when you author. This is a vector calculus problem created by Paul Pearson. What I want you to notice in this problem are some of the additional macros: parser vector utilities, parser parametric line, as well as this new context, the vector context. And in this context, Paul has added a real parameter to the set of variables. Paul has also used the math object point, the math object parametric line, and the math object line. Let's now take action to see what the student sees. Because math objects were used in this problem, the answer is robust. In other words, it's not a string. We could, for example, type t times this vector, and it's still correct. We could switch the order of the terms. And it would still be correct. One of the reasons why it's important to use math objects is exactly what we've shown here, that mathematical operations such as addition and multiplication are defined and have meaning for math objects. In contrast, if you simply compared a student answer to, say, a Perl string, students would have to type exactly what you had written or else get the answer incorrect. In this problem, you saw a variety of math objects, such as point, parametric line, and line. Just as there are many mathematical subjects, there are many other math objects that have been created, with many methods that make the creation of problems easier, faster, and more robust. Some examples are the vector object, the formula object, the matrix object, the complex object, the set object, and the interval object. All of these objects have methods such as evaluating a function at a point, multiplying two complex numbers, taking the transpose of a matrix, testing if a point is in an interval, and taking the union of two sets. There are many other operations that have been defined for math objects, and fortunately, many people have written guides to show you how to use those objects. As a starting place, I recommend that you go to the WebWork documentation wiki, navigate to authors, and then navigate to math objects, where you'll find a wealth of information on math objects and the operations you can do on them. We'll now move on to a few other constructs that will be important for you as you create your problems. Constructs such as partial credit and multiple choice. This is a problem created by Carl Yao, and it is a multi-question problem. Because it is a multi-question problem, Carl has elected to use show partial correct answers, which allows the student to get credit even if they submit fewer than all the answers. We now update the file and go to the student view of the problem. So if I check my answers, you'll see that 1 is correct, and the 3 that I didn't fill in were incorrect. This means the student can get partial credit on this problem. This is a calculus problem written by Paul Pearson, and while we won't go through the entire problem, the part I want you to focus on is the multiple choice and the radio buttons. So this is how you create a multiple choice problem. You give several correct answers. The ones that are under the extra method are incorrect, and you also can make a last multiple choice, which is, for example, none of the above. Paul has also included radio buttons in his problem, and that's different from multiple choice in that only one of those answers can be correct. So let's take a look at the problem. And you'll see that only one of the answers in part B can be selected, but multiple answers in part A can be selected. You've now seen some simple examples, some more complicated examples, some examples of math objects, partial credit, multiple choice, and radio buttons. You are now ready to start authoring.